From section 13, we will discuss chapter 8, managing the response to hazardous material incidents. And mainly we will discuss the classification of hazardous material. The first thing, let's start with something maybe you noticed before. When you see a red diamond on a chemical container, like this one that you can see on the screen, what comes to your mind? Fire, toxicity, or danger in general? These symbols are part of an international language, the hazard classes and divisions, that helps us understand the risks of chemicals instantly, no matter where we are in the world. So it's a common language between all the world. Chemicals are shipped, stored, and used every country. To keep workers, transporters, and public safe, there has to be a universal system to classify hazards. That's why organizations like United Nations or UN and agreements like Globally Harmonized System of Classification and Labeling of Chemicals or GHS were developed. So the idea is simple. Every chemical hazard falls into a class. Some classes are further divided into divisions or categories to show the level of danger. This system ensures that whether you are in Saudi Arabia or US, Europe or Asia, everyone speaks the same safety language. This table that you can see in the Fire Protection Handbook, actually this table is part of the complete table because they are 9 classes, but here I just show part of the table. As you can see, class 1, for example, for explosive and blasting agents, class 2 for gases, class 3 for flammable and combustible liquids, and even something like class 1 divided into division 1-1, division 1-2, and so on. So the table lists the classes and divisions, examples of material, and general hazard properties. These are the symbols or the placard that you can see on the containers. Each class and division has a placard like the one that you can see on the screen. So now let's go through the 9 major hazard classes recognized internationally, especially in transport regulation like the UN recommendation on transport of dangerous goods. These are often called the 9 hazard classes. Class 1 for explosive, as we discussed, and that includes substance that can explode or cause sudden release of gas and heat, and it has 6 divisions. For example, the TNT or fireworks falls in this category. Class 2, the gases, and these gases can be flammable, toxic, or compressed, like propane, chlorine, oxygen cylinders, all fall on this class. Class 3, flammable liquids, which include liquids with low flash point that can catch fire easily like gasoline or ethanol. Class 4, flammable solids, which include substances that ignite through friction, self-react or emit flammable gases when wet like sulfur, sodium or matches. Class 5, oxidizing substance and organic peroxides, and include materials that cause or enhance the combustion of other substances like hydrogen peroxide or ammonium nitrate. Class 6, toxic and infectious substance, which include chemicals or agents that are poisonous to humans or animals like cyanide, medical waste or viruses. Class 7, radioactive material, which includes substance emitting ionizing radiation harmful to health and environment, like uranium and medical isotopes. Class 8 include corrosive substance, like material that can destroy skin, metal, or other materials on contact, like sulfuric acid or sodium hydroxide. And last thing is class 9, which include miscellaneous dangerous goods. If the hazard from the material doesn't fit in other classes, but it's still risky, you can include this in class 9, like lithium batteries, dry ice, environmentally hazardous substances. So remember, these 9 hazard classes are the backbone of international chemical safety. They give us a universal code for hazards. They make transport, storage, and workplace safety consistent worldwide, and they help us as a professionals to take the right precautions. Now let's see the NFPA 704 marking system. This famous diamond. or in other words is the fire diamond. The NFPA 704, developed by NFPA for sure, and its goal to provide emergency responders, firefighter, medical teams, safety officers with quick, clear information about the hazards of a material. It's not about detailed data or chemical formula. Instead, it's a fast visual code that answers how dangerous is this substance to health, how easily does it ignite, could it react violently, and are there any special hazards? So the symbol, as you can see in the photo, divided into 4 quadrants. Blue for health hazard, red for flammability, yellow for reactivity, and white for any special hazards. Each colored section use number or symbol to communicate risk level. For example, the blue one, it can range from 0 to 4, with the 0 means no hazard and 4 can kill with short exposure, like ammonium might be scored at 3 because it's a serious risk. The red, for example, also range from 0 to 4, and 0 means won't burn, and 4 means extremely flammable, ignites easily at normal temperatures, like gasoline may be 3, acetylene is 4. Yellow is the reactivity or instability, again from 0 to 4. 0 means stable even under fire, and 4 means it may detonate or explode without warning, like TNT score high and water score 0. And for the white quadrant, uses symbols or letter instead of numbers, like these symbols: acid for acid material, ALK for alkaline, COR for corrosive, OX for oxidizer, and this symbol for radiation hazard, and the W with a strike through means don't put water on this material. So the NFPA 704 diamond is not just a sign, it's a life-saving communication tool. Blue tells you about the health, red tells you about fire hazard, yellow tells you about reactivity, and white tells you about special hazard.